Hello students, in today's video we will be learning about the order and a degree of the differential equation. Quickly we'll move on to you are very well aware the differential equation is nothing but an equation which involves the derivative. So you can see in all these examples what I've taken, all the derivatives are there irrespective of what order it is. Now coming back to the classification of the order and degree, we'll quickly just tell in the layman term we can define it as highest derivative in the differential equation. So we'll first just go through fast. So dy by dx, this is the first derivative. D cube, remember it is the 3 times that we are doing, so the highest is this one, therefore order is going to be 3. What about this one, y prime or y double dash? Basically it means double derivative, so that is the highest, so order is 2. So as in this one, if you find 3, 4, 5 like that, it means we are doing it 3, 4, 5 respectively. So here y 3 times, so it means the derivative is highest is 3. And here in this one, this is the first derivative, this is the second. That's how we represent it. So the order is the highest, that's why it is 2. We don't look it on the power, you have to look the derivative, how many times you are doing it. Coming back to this question, although it is of degree, but we can still find it out the order. The order for this is only that is given, so order is nothing but 2. Whereas in this one, again we have dy by dx within the bracket is first, here also it is first, so we've got 2 here, so order is going to be 2. Now coming back to find out the degree of a differential equation, first of all what you need to know, the 2 points that I have written here, it should be a polynomial in derivatives, first thing, and second thing is it should be the exponent of the highest order derivative. So first we should know, okay, what is the polynomial in derivatives means? It means basically the expression can be connected with either positive, negative, multiplication, and with the square, which is a non-negative integral powers. And if you have to go and check the degree of a differential equation for the given questions, what you have to look carefully is the dy by dx term should not be attached to the logarithmic, trigonometric like in this one, or the exponential, or with the inverse functions. So these 4 things, just keep it in mind where the degree is not defined. It can come separately though, like this one in this example, but it should not be attached with this one. The reason being is if you try and find out the derivative, infinite series it will form. That's the reason. So now first, as I told you, with the log, exponential, in these 3 cases degree is not defined. I have given you the reason for that. Now we shall quickly look at it, and remember this word polynomial in derivative and highest derivative in differential. So whatever is the highest order, its power you will see, that's it, exponent of the highest power, so that is nothing, it means degree is 1. Here the order was 2, but I told you exponential has that derivative, it means not defined. Whereas in this one, the order was 3 and its power is 2, therefore degree is 2. Since I have tick marked earlier because sign trigonometric is with the derivative, so degree is not defined. And for this one, order was 2, its power was nothing, exponent, so degree is going to be 1. That's how simply you can work it out to find out the order and degree. Now, these are some examples that I have taken to find out the order and degree. As I told you, it has to be for the degree, it should be free from the radicals. So we've got radicals here. What we should do is we should avoid that radical. So the order of this radical is 2. So we should square it. So when I square quickly, I'm going to get this one, and this will have square like that. So now if you can see, this is the first derivative, this is the second, so my order is 2, and degree, its exponent is also 2. That's how simple you can do it. What about this one? You can just cross multiply, and again the order is 2 of the root radical, square it on both sides, you will get your answer. Please do it yourself. Whereas for this one also, since we've got this one and they asked us sum, so what we are going to do is we will shift it to the other side. So this will give you negative cube root of dy over dx, whereas this you can write it as it is. Now you know within it's here itself we can get it. The highest derivative is 2, so my order is going to be 2. And if I remove this radical, that is which is the third order, so basically if I do the cubing, I'm going to get rid of this cube root. So basically now the degree is 3 because my highest order is 2, highest derivative. So 2 plus 3 is going to be 5. That is my